So what a awesome intro. I just want to thank the post-editing team for that one. And I'm excited today to talk to you all about molar math. Okay, so that's what we're going to take a look at today. We're going to get into a little bit about our first, or a little bit of our first homework assignment, molar math practice number 1. But before we do that, we need to first understand some of the terminology. Okay, so terminology, or term number 1, molar mass. So the molar mass is exactly what it states. It's the mass of any element found on the periodic table. It's the mass of 1 mole of that element. So when you're looking at the periodic table and you're looking at the masses, those are all the molar masses. Okay, those are all the molar masses. Chlorine, 35.45. Oxygen, 16.00. Hydrogen, 1.01. Those are all of the molar masses. They're always per 1 mole. Most of the time we'll say, for example, carbon, 12.01 grams per mole. It's the mass per 1 mole. It's found on the periodic table. Term number 2. Oh, I have some more examples for you guys. So 1 mole of chlorine is 35.45 grams. And 1 mole of oxygen, did I do oxygen? Yes, 16.00 grams. Now, if you couldn't tell already, I am recording this video while I'm watching the video that I previously recorded while writing. So you have to bear with me if I make a couple mistakes. If I say, hey, Fabs, what are you doing? It's like there's 2 of me. I recorded this that you are watching, and now I'm recording what you're listening to at a separate time. So we can also do this for compounds and molecules. It doesn't have to just be 1 element off of the periodic table. It doesn't have to just be nitrogen or chlorine or oxygen. We can have molecules and compounds. Compounds such as sodium chloride, NaCl. Looking at NaCl, we see that there is 1 sodium and 1 chlorine. So all you have to do is take the 1 sodium, 22.99, take the 1 chlorine, 35.45, and then you simply just add them. It is 1 to 1. When you add those, you get 58.44 grams. That would be 58.44 grams per mole of sodium chloride. Let's take a look at one more example before we move on. 1 mole of calcium chloride. Okay, so there is 1 calcium. However, at 40.08, however, we see something different there. Cl2. That little 2 down there, that subscript of a 2, means that there are 2 chlorines. So we have to multiply the 35.45 times 2 before we add it in. When we perform this calculation, we get a total molar mass for calcium chloride of 110.98 grams. All right, let's keep on keeping on, right? Another term that we have to familiarize ourselves with, or refamiliarize ourselves with, is that of Avogadro's number. Hey, 6.02 times 10 to the 23rd atoms, molecules, or particles. Avogadro's number is the number, or excuse me, the amount of atoms, molecules, particles, okay? The amount of atoms, molecules, or particles that are found in exactly 1 mole of any element, of any compound, of any substance. Please do not forget this number, 6.02 times 10 to the 23rd. Let's see, atoms, molecules, or moles. Good job, Fabs, good job. Oh, 6.02 times 10 to the 23rd. October 23rd is often called Mole Day, 10/23. And just for all you crazy cats out there who are on the Twitter, I think that's Twitter, hashtag Avi's number, right? Avogadro's number. I think that's how it works. Not quite sure. So, a couple quick examples. When we say we have 1 mole of chlorine and we want to know how many atoms that is, it is Avogadro's number, 6.02 times 10 to the 23rd. If we say we have 1 mole of hydrogen, or excuse me, 1 mole of water, how many molecules is that? 6.02 times 10 to the 23rd molecules of water. All right, not too bad, right? Not too bad at all. All right, so there is one more relationship that we just need to talk about, and this was in the previous video. This is the relationship between the moles, the amount of moles of a substance, and the volume that the substance occupies. It's the volume-mole relationship. So according for this relationship to be true, everything has to be under all conditions have to be under STP, which stand for standard temperature and pressure. And standard temperature is 0 degrees Celsius, while standard pressure is 1 atmosphere. Looking at this, 22.4 liters of any gas at STP, that's the standard temperature and pressure, standard temperature of 0 degrees Celsius, and a standard temperature of 1 atmosphere. So 22.4 liters of any gas at STP will equal exactly 1 mole of that gas. Excuse me. It's equal to 1 mole of that gas. My goodness, it's like I wrote this. Crazy. So, for example, 1 mole of nitrogen gas, N2, is 22.4 liters. And 1 mole of hydrogen gas, oxygen gas, a little too quick on the draw there, is also 22.4 liters. It's a very standard relationship. So, hey everybody, welcome back. So this sheet should look pretty familiar. Sorry, I must have a frog in my throat. This piece of paper should look pretty familiar. It is what you should have out right now. It is Mole Math Practice number 1. So the first thing we want to do is take a look at question 1B. I'm not going to do all these, just a couple to point out. I'm going to have to defer the rest to you guys so that you guys can get some practice. But looking at number 1B, we have 1 mole of mercury. So now let's look to the periodic table. The point of question number 1 is to find the mass. Now when we're talking about mass, we're talking about molar mass. So take a look at the periodic table and see what you can find with regard to mercury, Hg. All right, so the mass you should have found is 200.59 grams. That is per 1 mole of mercury. 1 mole of mercury taken right from the periodic table. Remember, made a little mistake there. Remember, 1 mole of any substance is also equal to Avogadro's number, 6.02 times 10 to the 23rd atoms. So that can be used interchangeably. If I say to you, I want 1 mole of chlorine, I could say the same thing as I want 6.02 times 10 to the 23rd atoms of chlorine. It's the same exact thing. So for example here, 6.02 times 10 to the 23rd atoms of hydrogen, that is interchangeable. That is just like saying 1 mole of hydrogen. That's equal to 1.01 grams of hydrogen. Taken again right from the periodic table. All right, let's look at number 2. How many moles are equivalent to each of the following? If we look at boron, we find boron on the periodic table. It is 10.811 grams. And we know that's the molar mass per 1 mole. So it's just 1 mole of boron. We're actually going to jump to 2D now. Looking at 2D, it's 3.011 times 10 to the 23rd atoms of silicon. Now, you're probably thinking, gee, that seems like half of 6.02 times 10 to the 23rd. And we know 6.02 times 10 to the 23rd is 1 mole, right? 6.02 times 10 to the 23rd atoms is 1 mole. So 3.011 times 10 to the 23rd is half of that, which means we now have half of a mole of silicon. Okay? It's those relationships you need to get quick with, you need to be comfortable with, you need to be familiar with. All right, so we concentrated so much on dimensional analysis and factor label method and unit conversion when we first started, right? Liters to kiloliters, to metric prefixes, feet to meters to kilometers, so on and so on. We did that all for a reason, and this is that reason. We're using those same skills to help us convert between units here. So in number 3, we're looking at the number of moles. You should all be in one-step problems. So X moles of zircon zirconium, X moles of zirconium equal 32.00 grams of zirconium. Now, the relationship that allows us to go from grams to moles and moles to grams is the molar mass taken from the periodic table. The molar mass of zirconium is 91.22 grams, and that is per 1 mole. Take a look, our grams of zirconium cancel. We wanted moles, we were left with moles. Now all you have to do is take 32.00 grams and divide that by 91.22 grams, making sure that you keep the same number of sig figs. There's 4 there, so we should have 4 in our answer. And we are going to get 0.3508 moles of zirconium. It's a simple one-step conversion using the molar mass. Let's try another one. Let's take a look at C. X moles, how many moles of gold, AU, is equal to 6.6 times 10 to the 6 grams of gold? Again, make sure you cancel. In order to cancel, grams have to go on the bottom, moles on top. Now again, grams and mole relationship, that is from the periodic table. That's the molar mass. Look it up on that periodic table. Pause this video if you need to. It is always per 1 mole, so 1 mole of gold is equal to the molar mass of gold. And the molar mass of gold, look it up, I'm giving you some time here. It is 191.97 grams per 1 mole. We cancel out the grams. We're left with moles. We wanted moles. All we do is take 6.6 times 10 to the 6th, divide that by 196.97, keeping 2 sig figs, because that's what we started with. We get 34,000 moles of gold, or if you write it in scientific notation, you get 3.4 times 10 to the 4th moles of gold. I'd want you guys to write it in scientific notation, because if you start in scientific notation, you should end in scientific notation. All right, let's take a look at number 4. We're moving through this pretty quickly. It's awesome. Now we're calculating the grams in one step again. So X grams of aluminum equal 3.5 moles of aluminum. In order to cancel, moles of aluminum need to go on the bottom. Grams would then go on top. From here, again, this is the molar mass. Grams and moles, that's molar mass. That's found on the what? The periodic table, you're correct. 26.98 grams for every 1 mole. Moles cancel. We wanted grams. We got grams. All we do now is multiply out 3.5 times 26.98. Remembering that we have 2 sig figs, and we get 94.43 grams. Ooh, I didn't round, I apologize. Should be 94 grams of aluminum based on 2 sig figs. My bad. So even teachers make mistakes, but it's okay. It's okay to admit that. All right, welcome back, everybody. We're on question 5 right now. Calculate the number of atoms in each of the following. It's still a one-step problem. So now we're looking at the relationship of moles to atoms and atoms to moles. That's Avogadro's number, 6.02 times 10 to the 23rd. Hashtag Avi's number. Am I right? Yeah. All right, so X atoms equals 3.2 moles of astatine, AT. So we have 3.2 moles. We're going to draw the zoop and zoop. Moles of astatine, they're on top. So in order to cancel, they need to go on the bottom. And we're going from moles to atoms. And you know the relationship of moles to atoms and atoms to moles? That is Avogadro's number, 6.02 times 10 to the 23rd atoms for every 1 mole. Moles of astatine cancel. We wanted atoms. We're left with atoms. Now all we need to do is multiply out 3.2 times 6.02 times 10 to the 23rd. Remember, we keep the 2 sig figs from 3.2. After that, our answer comes out to be 1.9 times 10 to the 24th atoms of astatine. I want you to try that next one for me as well. The next one has a -4, so be careful of that one. All right, now we're getting into some fun here. 2-steppers. So here we want to essentially attain atoms, and we're starting with grams. So X atoms of oxygen equal 21 grams of oxygen. Now, you cannot go right from grams to atoms. There's no step that allows it. But you can go from grams of oxygen to moles of oxygen, and then you can go from moles of oxygen to atoms of oxygen. And those are going to be our two steps. First step is a molar mass, grams and moles, 16 grams for 1 mole. The second step is Avogadro's number. 1 mole, 6.02 times 10 to the 23rd atoms of oxygen. Making sure that we're always canceling grams of oxygen to grams of oxygen, moles of oxygen to moles of oxygen. After you do this, we simply multiply out 21 times 6.02 times 10 to the 23rd divided by 16. Doing this, we're going to punch this into our calculator. Beep, boop, beep, doop, beep, boop, beep, boop. Sound effect. And we get an answer of, remembering that we started off with 2 sig figs, we get an answer of 7.9 times 10 to the 23rd atoms of oxygen. Wasn't so bad, right? All right, let's do one more example, and then I will cut you guys loose. You can finish this up on your own. Here we're going the complete opposite way. We just went atoms to grams. Now we're going to go grams to atoms. Vice versa. So how many grams of nitrogen are in 3.01 times 10 to the 23rd atoms of nitrogen? Again, we cannot go right from atoms to grams. You cannot. You first need to go from atoms to moles. Atoms on top, atoms on the bottom. Moles go to the top. Remember, this is Avogadro's number. For every 1 mole on top, we have 6.02 times 10 to the 23rd atoms on the bottom. The atoms cancel. Now moles on top, where do we put moles? Correct, they need to go on the bottom. Moles to grams, that is molar mass. For every 1 mole on the bottom, you have to look up the molar mass of nitrogen. That is 14.01, 14.00. Almost got it. So remember, that's found on the periodic table. Very important. It's the molar mass. Here we're going to take 3.01 times 10 to the 23rd. We're going to multiply that by 14 and then divide that by 6.02 times 10 to the 23rd. We wanted grams. We got grams. That's it. Doing this, make sure you round to 3 sig figs. Count them, 1, 2, 3 sig figs. And Mr. Fabs did not round to 3 sig figs. Yeah, page is moving around on them. It should have been 7.00 grams of nitrogen. The last question is simply just an isotope question. It's a weighted average question. Remember, the 2 pieces of information you need for weighted averages are the actual mass of each individual isotope, as well as the abundance. And the abundance has to be in decimal form when you do the calculation. So 87% becomes 0.87. So I wish you guys the best of luck here. Please email me, send me a Teams chat, and if you have any questions. Otherwise, good luck. Take care, everybody. Have a wonderful day. Mr. Fabs saying, have a wonderful day. Bye, everybody.